Welcome to 8.5 Part 2. We're going to continue with the properties of logarithms, expanding some situations here. Just to review, remember, I want every single different piece in the part not with the log, so everything I highlighted here, we want its own log, and we don't want any exponents when we're done. And remember back to example A, I had given you this shortcut that if I've got a fraction, anything on top is going to be positive, and anything on bottom is going to be negative. So if I look at this, when I split this up, log base 7 of y is positive because that's on top, and then both of these are on bottom, so both the 3 and the x squared both get a negative. An alternative way of thinking about it really quick, let me show you. You could think of it like this. But then when I split up the log statement, I would get the same thing anyways. So the shortcut just is, if you have two pieces on bottom, both of them are negative. Alright, last but not least, I can't have exponents. So I see I've got log base 7 of x squared. I would want to take this exponent of 2 and put it in front of the log. So I've got minus 2 times log base 7 of x for just that part. And then the rest of these, nothing has changed. Pause if you need to. When you have that down, flip over to the back. One more tricky thing that I want to show you, and that is sometimes they're going to throw you off by putting some square roots in there. Now the way that I can use a square root is by thinking of the square root power as a 1/2 power. Remember that the square root of x is really x to the 1/2. So what they have really given us here is log base 2 of x to the 1/2 on top, and then yz on bottom. At this point it's very, very similar to what we just did with example C actually. That means that the top is positive. That's positive right there. And then these two pieces on bottom are both going to be negatives. And remember, every single part gets its own log. Last but not least, we can't have exponents to have it be fully expand. So I'm going to take that 1/2 exponent and stick it in the front. And I'll be lazy this time and just move it instead of rewriting it. That is acceptable. Alright, let's look at E. And if you want to at this stage, you can pause it and try E and F. These ones are more difficult. But go ahead and pause it and try it if you want to, and then you can fast forward and check your work. What I want to think about for this part in E is that that square root is over the entire thing. And remember your properties from chapter 7. That means that I can split it up into the top and the bottom separate. And then also, because a square root is a 1/2 exponent, let's just immediately think of it like 10 to the 1/2 then divided by t to the 1/2. So I took the square root, I split it up, and then I changed the square root to a 1/2 exponent. And now you can see that I've got another quotient property going on. So I'm going to have log of 10 to the 1/2, and notice this is a common log, no base. So when I write my log each time, there's nothing there that I'm going to write. And then the part on bottom is negative. Last but not least, move your exponents to the front of each statement. So I've got 1/2 log 10 subtract 1/2 log t. Alright, I guess that wasn't that difficult. Let's try F. For this one, I see it kind of just straightforward right away. It looks like I have the product property because I see that I got 64x squared is really 64 times x squared. I've got log base 8 of 64 then plus log base 8 of x squared. And I want to move my exponent, but also if you have a log that you know, go ahead and go for it. Here's what I mean. If I think, okay, what power of 8 gives me 64? I actually know the answer to that one. That one is 2. So actually find the log if it is something that you know. Alright, pause, make sure you got that down, write down questions. Let's look at example 4. And example 4 is basically the same thing, only we're going backwards. So now they're going to give it to you all written out. And our goal is to make it so that it's all together. So our goal is a single logarithm. And our goal is to have to have exponents. And I want to tell you that before, remember how I always moved the exponent to the front at the very end? This time we're going to do that first. So we're going to move the powers to start off with this time. Let's look at part A. Move your powers first. My first step then is to move this so it says log base 2, not log base 2, but log of 2 squared. And it is fine, actually, class, if there are things that you can actually multiply together or take the power of and that kind of thing, go for it. So I know that 2 squared actually is equal to 4, so I will say log of 4. All right, now let's use our properties. And when we're condensing, sometimes it helps students to think of doing it one at a time if needed. The same rules apply as what I said before, which are if it's positive, it goes on top. And if it's negative, it goes on bottom, based on that sign there. So let me show you the long way though, just to start off with, but then you can use that shortcut once you get the hang of it. So the long way is just do it one step at a time. So first I'll condense these two. So because it's a plus sign in between, I change it to multiply, and the logs drop, so I just have a single log. Now condense these. So now this will be on top, this will be on bottom because it's a subtract. So I got log 6 times, you know what, 6 times 4 is 24, so I'll say 24 on top and 3 on bottom. And then 24 divided by 3 is 8. So log 8 is my final answer there. Let's look at part B. Again, do your exponents first. This means I end up with log base 3 of 7 squared minus log base 3 of x to the 5th. Again, you can actually find the answer if you want to. This time I'm going to wait a second just to show you something here. This time I'm going this way and I have the quotient property again, so that means that 7 squared is going on top. X to the 5th is going on bottom. And remember, our goal is so that there's just a single log left and everything's with that single log. So I have achieved my goal if I just have log base 3 of 49 divided by x to the 5th. For part C, I want to show you what happens when I've got two different things on bottom. Check this out. So when I look at this, I'm going to first move my power again. So you know what? Let me be lazy again and we'll just kind of cross that out and make it an exponent. Okay? Now, remember how I said anything that was negative before was the bottom and anything that was positive was the top? So let's try to do this all in one step and see if this makes sense. So what I mean is x squared, 5, and y cubed are my 3 different pieces. Log base 8 is the log I'm using. So these 3 pieces, I got to figure out which one goes on top, which one goes on bottom. I know it's a fraction because I see subtracts. Alright, x squared is positive, so that goes on top. And the 5 is with the negative log, and the y cubed is with the negative log. So 5y cubed on bottom. I can definitely go through that again if needed tomorrow in class. Pause it, get it down, move on to part D. If I get a fraction that I can actually convert to a square root, you do want to actually do that. So for part D, I'm going to move this, but when I do a 1/2 exponent, I get log base 3 y to the 1/2, but a 1/2 exponent is the same thing as a square root. So let me say that again. So I had a 1/2 exponent there, but a 1/2 exponent is the same thing as a square root. So I've just converted it to square root of y there, and I just have a plus sign this time. So nothing too fancy is going on. If it's just a plus sign, use your product property. It's going to be 2 times square root of y when I combine my 2 pieces, and log base 3 is the log part of it. I'm going to keep going. I'm going to go a little faster at this point, so just make sure that you pause the video if you need to. Few things I want to show you for this one. First of all, I got a negative sign in front of a parentheses. We are going to distribute that just like a normal math problem. So this is going to be subtract for that one, and then a negative is going to be plus. I will move my exponents right away. So I end up with ln of 27 to the 1/3 power. I end up with ln of 3 squared. Notice the negatives are not moving with the exponents. The negatives are not moving with the exponents. ln of 16 to the 1/2 power. In this situation, all three of these are powers that I can actually do. So 3 squared is 9. 27 to the 1/3 power, try typing that into your calculator and you should get 3. And then 16 to the 1/2 power is like the square root of 16. Square root of 16 is 4. Now, notice that only this middle one has the negative log. And remember, ln log, same rules apply as log log. So, ln is my kind of log. These three numbers I just highlighted are the different pieces I have. I just told you 9 is going to go on bottom because that's the negative one. That means 3 and 4 are multiplied together on top. So I got ln of 12/9 or ln of 4/3 if I reduce it. Go ahead and pause the video and try part F. Alright, unpause, check your answer. If you need to pause it and look at what I did, feel free. I'm going to move on though because we're running out of time for this video. Change of base formula is next, and once I teach you this, you're going to wonder why I didn't tell you sooner, but we didn't tell you sooner because we always want you to try to do things as much in your head with mental math as possible. But I'm going to show you now. Let's say that I did get a statement like log base 3 is 6. That's one I can't do in my head because I don't know what power of 3 gives us 6. So we're going to use something called the change of base formula to type this into our calculator. Here's the formula. Let's say I had log base c of u. So c and u are just two real numbers. This changes into log of u divided by log of c. Log of u divided by log of c. And notice that what I've done right here is both of these are base 10. Both logs are log base 10, and the reason I wanted to do that is because log base 10 I can type into my calculator. You could actually change it to any base you wanted to, but you never see anybody doing other bases because the main reason we use this formula is so that I can type something into my calculator. So let's try this. So look at example A, and here's how I remember this. Let me tell you this. I remember the big number goes on top, the base goes on bottom. That's how I remember it. So if I was can't do that by my head, so I'm gonna use my calculator. Big number goes on top, little number goes on bottom. So I'm literally gonna type into my calculator log base 6 divided by log base 3. Make sure you close parentheses if your calculator is one that adds a parentheses, and you should end up with 1.63. So go ahead and pause and try it in your calculator. So again, every single time big number goes on top, base goes on bottom. Type it in your calculator, see what you're getting. Go ahead and try C and D. And B if you didn't do so already. Go ahead and try C and B, and let's just make sure that you know how to do this correctly in your calculator. This is one part that students usually love because it's super easy. Ooh, log of -4 for D. Now notice this one already is base 10, so the only reason I changed the base is because it's not base 10. So this one already is base 10, so I don't have to do the change of base. But when I type this into my calculator, you get an error message. My question is, why? Why would I get an error message? We're going to talk about this more in class, but I'll show you quickly now. The reason I would get an error message is, this is the problem I'm trying to solve. What power of 10 gives us a -4? When I'm doing an exponent like this, and this base was positive, it's just not possible to turn it into a negative situation. Because if I use a negative exponent, it actually just turns this into a fraction. For example, this. If I use a fraction exponent, it just takes the square root. If I use a positive exponent, it just finds the number. So there's no way, no exponent I could find that would make it negative. So whenever I have something like this, it will be an error message. Now, one more quick. Look at log base -4 of 16. So this time I'm trying to do -4 squared equals 16. Now if you try this one is possible because x could be 2, but if you try it this way,